Let's start with a little bit about three-phase distribution. And what are some of the constraints and challenges that you see?
There are a lot of constraints and challenges to providing power conversion technologies in an industrial or three-phase power level. For two of the approaches I can speak to, it comes down to space, density, and providing industrial three-phase power in the size, efficiency, and ease of use that looks more like a conventional single-phase power solution.
So Jim, before we dig into the space-saving solutions, can you tell us a little bit about the constraints for three-phase distribution?
First, most power engineers already use commercial three-phase power, but they split the three phases into single phase for consumption by the server blades in the rack.
What kind of challenges?
The data center operator is faced with the challenge of ensuring that each phase is evenly loaded. Uneven phase balancing creates a headache for the power generation utility, which is challenged with providing efficiently priced electricity for the data center. They see phase imbalance as an energy waste, and that has an impact on energy cost.
So Jim, where's the density solution here?
So there are two levels where we can help with density. One, we've created a compact three-phase AC to DC 6 kilowatt rectifier called the GP100 that inherently balances the AC load. So the data center operator doesn't even have to think about it. Sophisticated load balancing algorithms and schemes can simply go away. And then we're taking space density one step further by reclaiming space in each data center rack. By taking up much less space than conventional three-phase power supplies, we're delivering the same amount of space in half the rack space, and also by eliminating the need for a separate power distribution unit to split the phases. We simply connect all three phases directly to the power supply. The result is that we're freeing up server-based space to be used for extra compute capacity.
So really giving back 2 or 3 bays in every row.
But that's just the start. In a brainstorming exercise, we asked, what if we could eliminate power conversion from the data center racks altogether? By looking at all the allocated space in a data center rack, we landed on the idea of moving the power supplies and the power distribution unit out of the server space, but yet keep them in close proximity to the server loads, so the total solution is very efficient in both its use of space and in its use of power. We moved the PDU to the back corner of the rack, out of the way, and made the power supplies front pluggable.
So we've moved the power to an area of the cabinet that was previously unused.
That's right. And if you consider the cost of each server cabinet, its purchase and installation cost, infrastructure and white space floor costs, it's millions of dollars we're giving back, and up to 10% of the space to be used for more processing power. Multiply that by hundreds of server cabinets in just one data center, and you have some idea of the value that good power design gives back in real estate and other costs.
Thanks, Jim.